Java is an object-oriented programming language, but I have my questions around it after the introduction of Lambda Expressions. Java, after all, isn't strictly object-oriented programming. We're going to talk about Lambda Expressions and Method References in this chapter. Stay tuned.
In this chapter, we're going to talk about Lambda Expressions. First of all, let me clarify that Lambda Expressions are like icing on the cake. You can live without Lambda Expressions. But that being said, Lambda Expressions offer you to write a clean code that is easy to understand, more readable, and hence, as a byproduct, you get a more maintainable code as well, and that too with minimal set of instructions. Also, Lambda Expressions have a significant role when used with Stream API. But in this chapter, we're just focused on understanding Lambda Expressions and method references. We'll talk about Stream API at a later point of time. In this example, I've just created a couple of string objects and I'm passing them as an argument to this method display, and all this method is doing is display the string on the console. Now what I wanted to accomplish here is I want to send a piece of code, some code here, and I'm going to pass this code as an argument to this method, and this method would execute that piece of code. How do we accomplish this? For this purpose, I'm going to create an interface. Let's get rid of this first. Let's call this method execute. That would make more sense. So let's create an interface. And just as we have a member class, we can have a member interface that will have the scope of this class. Interface, I'm going to call it math interface. I'm going to define exactly one method in here. Void find sum. Now what I want to do here in the main method is I want to create a class that is local to this method. Class sum name implements math. Now by doing so, we need to provide implementation for the only method present in this interface. In this case, I'm just going to say sysout 10 plus 10. Now in the next step, I'm going to create an instance of this class. Sum name object new sum name. But as I've already mentioned, when you're going to create an instance of a class that implements an interface, always have interface as the reference type. It's a good practice. Now we can send this object to this method, but we have a problem here. The type of argument that this method is expecting is string. So we need to change this to math type, and let's call this obj. That would make more sense. And in here I'm going to call that method find sum, and obviously we can now pass this object as an argument and compiler will not complain. In here we have declared the class and then we instantiated that class to create an object. We can do these two steps in one go with anonymous inner classes. If you want to know about anonymous inner classes, then please go back and take a look at my video on the same. So let's make this an anonymous inner class. It's going to have the following syntax. Now we can get rid of this. Pretty well and good. Now we kind of accomplished what we wanted. We have a variable which is of type math, and we have some kind of a block that would constitute the code that we wanted to execute. And when we pass this object as an argument to this method, we're calling the method findSum to execute that block of instructions. Let's run the program. So we kind of accomplished what we wanted, but not exactly true, because if you take a look, although we're just interested in executing this statement, there's a lot of junk in here we're passing. We're creating a class, instantiating it, and then we're passing that instance or an object to this method. So essentially, we still didn't accomplish our task of sending a block of code. We're not sending block of code that we want to execute. We're sending an object that has block of code. Now at later point of time, let's say you wanted to have another implementation of this math interface, and for that you're going to create another set of 10 lines, call it object 1, and then you will pass it as an argument. This is kind of like an overkill. We're not only sending this block of instruction, along with that we're also sending an object that wraps this code. In our next video, that's what we're going to talk about. We're going to take a look at how we can send a block of code rather than an object that has that block of code. See you in my next video. Alright, let's continue. To explain lambda expressions in better fashion, I'm going to copy this section of code into a notepad. Now pay attention to the code that I've just selected. Majority of this code is pretty obvious to compiler. I mean, compiler can figure out majority of this code without you telling it. For example, when you have reference type as a math interface, it's obvious that the only possible anonymous class you can declare on the right hand side of this equal sign is the class that implements the math interface. You can't have an anonymous inner class that can implement any other interface. That would result in a compile time error. So we can get rid of the declaration part here. We don't want to tell compiler that we're creating an anonymous inner class and then we're implementing the math interface. It can figure that out by itself. We're going to get rid of this ending curly brace as well. Now when you don't declare the class, we cannot create an instance of that class. So there is no meaning of having the new operator in here. Now since compiler is aware of this interface, it can easily know the name of the only method present in that interface is findSum. Now do we need to tell compiler the type of value that this block of code is returning? We don't have to. Compiler can easily take a look at your code and can figure out the return type. For example, in this case we're just using sysout statement, which means we're returning nothing. So compiler is smart enough to know just that. You don't have to tell that again. In case if you use a return statement to return a string or a custom object, compiler can figure that out as well by itself. You don't have to tell it again. Now public is an access specifier. Access specifiers would make sense when you have them in a class and when you create an instance of that class to try to access those methods. In this case we don't have a class, we don't have an instance with the new operator, so we can get rid of this as well. Now again, you don't have to provide this annotation because there's just one method. Whatever the implementation that you have in here has to be implementation of the only method present in that interface. So we can get rid of this as well. So this is what we're left with. Now there's just one step to make this a lambda expression, is to use the newly introduced operator that just looks like an arrow, something like this. And every statement in Java ends with a semicolon. This is no exception. Now let's copy this section of code. Let's go back to our Eclipse environment and paste it in here. Guess what? There is no compile time error because what we've just accomplished is exactly what we wanted to accomplish. Well, we can actually shrink this code further by eliminating these curly braces. The reason is we're just having only one instruction. There is no meaning of having them wrapped around these curly braces. If you have more than one instruction though, you need to have curly braces. But we're going to talk about it later point of time. For now we can get rid of these curly braces without any problem, and compiler will not complain. Now guess what? We have a section of code. In this case it's just one instruction. If this was more than one line, we'd have a block of code. So we had block of code and we gave that block of code some name, which in this case is obj, and we also have a type. Just as in here, for a string like say apple is of type string, this code in here is of type this interface. And now we're sending that variable to this method, and this method is able to accept it because the method is going to accept the same type, the math interface. So again, we have just accomplished what we wanted. We're able to pass a block of code or functionality, or in Java terms, the behavior as an argument to this method execute, and we're able to execute that behavior inside this method. Similarly, we can also make this anonymous class a lambda expression. So let's see how we can accomplish. I'm going to copy this, paste this, and then have this instruction in here. Of course, let's change it to say 20 or whatever. Let's call it object 1. Let's get rid of this now, and everything works smoothly without any problem. So we're going to see the sum of 10 and 10, and then we'll see the sum of 10 and 20. Great. So we have also reduced the number of lines of code quite a bit. Also, although you don't agree with me at this moment, this code is more readable than using anonymous inner classes, provided that your brain is used to interpreting lambda expressions. You'll be used to it once you start using the lambda expressions. I'll walk you through some of the examples anyway. Also, if you're aware of functional programming language, you would realize that with lambda expressions, Java is trying to switch its gears, but not really. Java follows object-oriented programming paradigm, and it always will. But object-oriented programming is an overkill at certain situations. So it's okay that the Java designers decided to introduce some functional programming into Java world. And in fact, this is one of the eagerly waited features by all the Java developers in the current market. I hope this makes sense. In our next video, we're going to take a look at some more examples of lambda expressions so that you will get a better sense on how to use them. See you in my next video. Okay, let's take a look at couple of more examples of lambda expressions. In this class, I have the exact code from our previous example, except now this method would accept a couple of parameters which are of type int, and I'm finding the sum of those two arguments. In here I'm passing the two arguments that I wanted to get the sum of. Let's run the program. Now how can we convert this into a lambda expression? Let's go step by step. Again, we're going to get rid of the class declaration, and since there is no purpose of new and public access specifier, let's get rid of them. Again, compiler can figure out that this set of instructions, or in this case just one instruction, is not returning anything, so you don't have to have the return type. The name of the method is something that the compiler can figure out by looking at the reference type, which is math. We can get rid of this, and of course no override, because the only method that we can possibly override is the only method present in that interface. Let's get rid of this as well. Now we're going to have this arrow symbol, and we're going to end the statement with a semicolon, and that's it. And again, since it's just one line of code, we can get rid of these curly braces as well, like so. And guess what? What we have here is a lambda expression. Now we can further shorten this line by a few characters. Again, some parts of this line can be figured out by the compiler. By that I mean, even if you don't tell compiler the type of argument that are going to be passed in to this method, it can figure that out by looking at the method in this interface math. So still, compiler does not complain, everything works just well. Now what if you have some kind of a return type in here? And that's what we're going to talk about in this example. Let's have return type as int. Same goes in here. And this method is going to return the sum of those two arguments. Return. In here, let's use sysout statement just to display whatever is being returned by calling this method findSum. Let's run the program. Let's try to convert this into a lambda expression. We can get rid of this and everything in here have the arrow mark. Pretty well and good. And again, since it's just one line of code, you can have everything in one line. But we have a problem here. Compiler does not want us to use the return statement because it knows that it needs to return int because it is aware of the interface and it knows the return type of this method. Let's get rid of this. Now guess what? This will work just fine. Let's run the program. But obviously, when you have more than one line of code, you need to wrap the code around the curly braces. For example, let's say I'm going to say int x equals a plus b, and I'm going to return x. In this case, we need to tell the compiler what we want to return, because say we have another line, something like this, compiler cannot figure out whether to return x or y. We need to tell the compiler. But whereas if you have just this part and you have it in one line, just as we had looked at a moment ago, in that case you don't have to use the return keyword. Let's get rid of this. Save the file. Pretty well and good. Also, one thing which is worth mentioning is that lambda expressions would work only when you work with an interface that has exactly one method. For example, in this case, if you have another method defined in here, compiler does not know to which method is this implementation belong to. In this case, anonymous class is the way to go, or create your own class and have this interface implemented. But if you want to use lambda expression, you would need to have exactly one method in your interface. Let's get rid of this. But there is a possibility that somebody can accidentally make changes to the interface, and that would affect the entire project, and it will impact all the areas you used the lambda expression based on that interface. So one way to avoid that is by using an annotation functional interface. And with this, if you try to define one more method in this interface, it's going to throw a compile time error saying invalid annotation lambda example.math is not functional interface. So we're forced to get rid of this. Alright, see you in my next video. In this video, we're going to talk about method references. But before that, let me just quickly talk about one of the good practices to follow when writing a lambda expression. In our previous example, we have a lambda expression that has a section of code spanning across more than one line. Now, if you remember, one of the primary reasons why you use lambda expressions is to reduce the number of lines of code and increase the readability. But this lambda expression is sort of destroying that purpose. We're having more than one line of code, and so we have to introduce additional lines with these curly braces. So it's always important that you keep lambda expression in just one line. How do we do that in this case? Just cut this code from here, create a method. Let's call it just math. And this method is going to take in exact same arguments, int a, int b. Of course, these arguments can be of any name. And then you'll have that block of code. Now from here, of course, this is going to return int. Now in here, what you can do is you just call this method like so, and just pass those parameters to that method, and that's it. Now we have the lambda expression in just one line. Now this is definitely a good practice because of another reason is you can have a better exception handling. You can have a try-catch block in here, and then you can handle the exceptions as you would need. But if you were to handle the exception in the lambda expression, again that's going to add up additional lines of code, and it would more or less look like an anonymous class, which will destroy the sole purpose of using a lambda expression. So I just want to let you know the good practice. Now let's talk about the method references. For that purpose, I have this example. I have a couple of interfaces in here. In one of the interfaces, I have a method without any arguments, and in interface 2, I have a method defined with just one argument, which is a string. And then I just have one static method and a non-static method. In here, I have 3 lambda expressions. In the first one, I'm making use of the interface 1, and I'm kind of providing the implementation for the method. And the implementation is just calling this method, static method, which has the actual code. It just prints one message. This statement is somewhat equivalent to this with no arguments. And in here, I'm using interface 2, and I'm providing implementation for this method. It's going to accept one argument. We have that in here, and passing that argument to the println method, like so. Similarly, we have another lambda expression of interface 1, and this time we're going to call the non-static method. And for that, of course, we need to create an instance of this class method reference example. That's what I did here. And all I'm doing in these 3 instructions is just call the method defined in these interfaces. Let's try to run the program. The output is as expected. Now, if you observe, there are a couple of things that are common in all these lambda expressions. Those are, number 1, the only instruction you have in these lambda expressions is you're just calling one method. And number 2, you're not making any kind of modifications to the parameter that you send to this method. For example, here we don't have any arguments, and so we're not passing in here. And in here we're having one argument, and we're passing it to the println method as an argument. And in here, again, no arguments, and we're not passing anything. If these 2 conditions are met, then we can use method references. So in this case, instead of having this kind of expression in here, what you can do is, since this is a static method, you can use a class name and then use a couple of colons like so, and get rid of these parentheses in here. And guess what? What you have in here is a method reference. So what this basically means is you're just telling the Java virtual machine that go call this method in this class and pass the list of arguments as it is to this method. Again, it's never mandatory to use method references instead of a lambda expression. In fact, I personally feel lambda expression is more readable than a method reference, but at times this might come in handy. So it's okay even if you don't watch this video, to be honest. method references are just like an alternative representation of lambda expressions. Let's take a look at a few more examples so that you get a sense of what method references are. So in here, again, this lambda expression qualifies for those two conditions. Number one, the lambda expression has to have only one instruction, and that too calling a method. In this case, we're calling the println method. And condition number two, we're passing the argument as it is to this method as an argument. Since these two conditions are met, we can certainly make use of method references in here as well. So we get rid of this piece of instruction and just add a couple of colons and get rid of parentheses and everything inside it. So again, what this means is you're telling the Java virtual machine that go call this method and pass the arguments exactly as it is to this method. In this instruction, that's exactly what we're doing. We're calling this method and then we're passing some kind of an argument in here. And that argument would be passed as it is to the println method. And we know what the println method does. It just prints that string onto the console. How about a non-static method residing inside a class? For that, obviously you need to create an object and then you call that method. And the way we do it with method reference, by the way, even this lambda expression qualifies our two conditions. So we get rid of this and the parenthesis, and we're going to use a couple of colons, and that's it. You have the method reference. Now let's go back to our previous examples and see where we can use method references instead of a lambda expression. In this example, we have a lambda expression that just has one line of code and we're just calling a method. So condition number one is met. Condition number two, we need to pass the argument as it is to that method. In this case, we're not doing that. We're passing in some kind of an argument, when in here we don't have any arguments. So this lambda expression doesn't qualify for method reference. If this method does not have an argument, then we can make use of the method references. Same in here, you cannot use a method reference. Let's go to this example. Even in here, condition number one is met, but condition number two didn't meet because we have a couple of arguments being passed, and we're not really passing those two arguments as it is. We're making some computation here. We're finding the sum. So even this lambda expression does not qualify for method reference. Let's go here. In here, we have a couple of arguments. By the way, we can get rid of the data type in here because compiler can figure that out by looking at the interface. So let's get rid of this. Now in here, we have only one line of code, and that too calling a method. And condition number two is also met because we're passing the arguments as it is to this method. So guess what? We can use the method reference. Since this is a static method, we can say class name double colon and the method name. And of course now we can get rid of these arguments, these parameters in here. This worked like charm. Also, there is one more addition in here. Since we are just passing this as an argument to a method only once, why don't we just directly pass this method reference as an argument directly without having to create a reference type? Because now compiler can figure out to which interface does this lambda expression or a method reference belong to by just looking at the argument type being accepted in this method. And same is the case with our previous examples. In fact, we can just copy this lambda expression in here and then have it in here. It's just fine. Let's save the file. Now I hope you got a sense of what method references are. And if you're still with me, let's also talk about constructor references. So instead of sending a method reference, you would send a constructor reference. And that's what we're going to talk about in this example. In this example, I just have one interface with one method which takes in one argument, and I have an implementation of that method using an anonymous inner class. And the implementation part, all it does is return a new string object. Essentially, this instruction would call the constructor of the string class. The string class has multiple constructors in it, one of which is going to accept a string as an argument. Now, we can certainly make this a lambda expression. We get rid of the class declaration part, and since there is no class, no meaning of having a new operator, again, all this information can be picked up from the interface being referenced. We now have a lambda expression. Of course, we need to have arrow mark. Again, since this is just one line of code, we can get rid of these curly braces and also the return type, because that can be figured out by the compiler just by looking at the interface. We don't need the data type in here. Now, is this lambda expression qualified for method reference or a constructor reference? The answer is of course yes, because condition number 1 is met. We're just calling one constructor instead of a method. And condition number 2, we're passing the arguments as it is to this constructor. So all you're going to have to do is you're going to say the class name string double colon and say new. That's all there is to it. Now you may ask me, which constructor does this constructor reference call? It depends on the type of argument being passed in here. Since this is a string, this is going to call the constructor that accepts exactly one argument and of type string. Let's run this program. Pretty well and good. Hope it makes sense. See you in my next video. So far, whenever we created a lambda expression, we're also required to create an interface to represent the type of the lambda expression. Wouldn't it be nice if we don't have to create an interface on our own and use one of the predefined interfaces provided in Java libraries? In Java 8, a new package was introduced just to serve that purpose. We have java.util.function package that has set of predefined functional interfaces, and each one of these interfaces has a method defined with a variety of combinations of method arguments and return types. Depending on your requirement, you can use one of these. It can be better explained with an example. In this example, we have 3 interfaces. In interface 1, we have a method that's going to accept one argument, which is of type string, and is going to return string. In interface 2, we have exact same method, except it doesn't return anything. In interface 3, we have a couple of arguments. One is of type string, the other is of type integer, and the method is going to return string. We also have their corresponding lambda expressions. Also, by the way, this lambda expression can be shortened. It's just for your purpose of readability. I have declared the lambda expression like so, but otherwise you can get rid of the angular brackets in here because it is just one statement, and we cannot have a return type in here when you don't have angular braces, because no compiler can figure out the return type by looking at the interface. Let's run the program. Now let's see if we can make use of one of the predefined functional interfaces for this lambda expression. We have interface 1, and that has one method. If you ignore the name of the interface and the name of the method, in essence we just have a method that's going to accept one argument and is going to return something. Let's see if we have an interface in the function package that does exactly same. If you go down a little bit, you'd find something called function, which is the name of the interface. If you read the description, it says represents a function that accepts one argument and produces a result or returns a result. This is exactly what we wanted. Also, if you observe, there are a couple of type arguments. Let's see what they're doing in this interface. we got T and R. T is actually the generic type, basically the type of argument that you pass into this method called apply, and is going to return a generic type, or in this case. So now we can certainly make use of this interface in our example for our first lambda expression. Let's see how we can do that. So in here, instead of saying interface 1, I'm going to make use of that interface called function, which is going to take a couple of generic arguments, string and string, because we want the method argument to be of type string, and I want the method to return a string. Now that's it. All you have to do is to import this interface by doing Ctrl+Shift+O, and of course we get an error here because setString is something part of our interface. Now this needs to be apply. Now the program works smoothly, just as before. Let's get rid of this interface. Now let's see if we can do something to the second lambda expression. In interface 2, we have a method that's going to accept one argument and no return type. In here, we have something called a consumer interface. If you read the description, that says represents an operation that accepts a single input argument, which is the generic type T, and returns no result. So let's copy this and paste it over here. This is going to be of type string. Let's do Ctrl+Shift+O. That's it. Now we can get rid of this interface. Similarly, for interface 3, we have something called by function. T and U are the two arguments that the method will accept, or is the return type. Let's copy this and use it in here. One argument is of type string, the other is of integer, and the return type is string as well. Of course, we need to call the methods defined in them, which is going to be accept in this case, and in here it's going to be again apply. That should do the trick. Everything works fine. Now we have reduced the lines of code, but at the cost of something. The problem with this is the naming. If you look at this, the name consumer, it might be confusing a little bit because we're not really doing something like consuming the elements or whatsoever. Our intent in here is different. Only the name is confusing. Even the methods that you're calling, apply, accept, doesn't really make sense in our case. But why am I explaining you this? These predefined functional interfaces will come into picture when we talk about Stream API. For that, wait for some time. But that's it on this video. See you in my next video.
In this video, we're going to take a look at the key difference between using an anonymous class versus lambda expression. We may think that lambda expression is a compact way of writing anonymous classes. Or some of us may assume that whenever we write a lambda expression, the compiler is going to replace the lambda expression with anonymous class. But that's not the case. They both are completely different. Let me demonstrate that with an example. In this example, I'm creating a couple of threads and I'm starting them. Let me just try to run this program without creating these threads. I run this program. Obviously, you won't see anything on the console. Now let's go to the folder where the .class file is generated. I mean the bytecode. For that, I'm going to right click on this file and then click Properties. Copy the location of this project. I've already done that. In here, go to bin directory. The source directory would constitute all the source files, .java files. And if you go to bin directory,
you would find their corresponding .class files, compiled files or bytecode, ready for JVM to process. Now if you notice, for our class Lambda example 2, we just have one class for that. But let's see what's going to happen once I uncomment those two anonymous classes. So let me just uncomment this. Let me run the program again. Now if you go to the bin directory, you would notice there are a couple of more files created with $1 and $2. These two are the .class files of the anonymous classes we created inside the Lambda example 2. So what this means is we got two anonymous classes for each thread, and so we got a couple of additional .class files. Now let's replace these with Lambda expression and see what's going to happen. Of course, we can get rid of these curly braces and the semicolon like so. And same thing goes in here as well. Let's call it from T2. Let's run the program and you would see the output as expected. But if you go to the bin directory now, you won't see those extra .class files. The reason why the compiler did not generate the .class file is compiler treats Lambda expressions differently. When you write a Lambda expression, we're not talking about classes and objects, which are object-oriented programming terms, but we are talking about actions to be performed or functionality to be executed. As I've already mentioned earlier, that when you write a Lambda expression, you need to start thinking differently. You need to think in a manner that a functional programmer thinks. But since we're not much into functional programming, we don't need to know anything more than this. But just remember that Lambda expression is not an easy representation of anonymous classes. I just want to clarify that with this video. Alright. One of the primary reasons why default methods are introduced in Java 8 is to let the API developers make use of the benefits that Lambda expressions offer. Let me explain you what I mean with an example. In this example, I've just created an array with 10 elements and they're all are of type integer, and I've just converted that array as a list and I've stored all the elements in this list. In here, I'm just looping through each and every element and I'm finding the product of each element by itself. So the first time that the controller enters inside this loop, it's going to be 1 multiplied by 1. The second time it enters, it's going to be the second element, which would be 2 multiplied by 2. Similarly, we're going to find the product for each and every element in this list. Let's run the program and see how the output looks. Now let me write the same section of code which I've just selected differently using a Lambda expression. And for this, I'm going to make use of a method that is in the list interface. That's called forEach. And if you notice, it's going to accept one argument, which is consumer. If you remember, consumer is a functional interface, part of the function package. We had already talked about it earlier. Here goes the Lambda expression. So for each element, what we want to do is exact same thing what we have here. E multiplied by E. Let's comment this code and run the program. The output is going to look similar. So what is the difference between this code and this code? Of course, this took less number of lines, but there is one significant difference between these two. In here, as a programmer, you need to tell the compiler how to loop through these elements and what needs to be done on each element. But whereas in here, you're not telling the compiler how to loop through the elements, but you're just focused on what needs to be done on each element. There is a difference. And again, this is a feature of functional programming. You would focus more on what needs to be done than how it needs to be done. Now, since in this case, you're not telling the compiler how to loop through each of the elements, as it is taken care by the for each method, this is called internal iterator. But whereas in here, you're explicitly telling the compiler how to loop through each element. So this is called external iterator. Also, you may argue that you can use for each loop in here. Still, you're telling the compiler how to loop through each one of these elements. For example, you could say for each element of type integer in the list, you want to do e multiplied by e. So this is still an external iterator. So whenever possible, always use internal iterator. But if you want to have control on how to loop through each element, for example, let's say you wanted to use break statement when a condition is met. In that case, you would better use an external iterator like for loop or while loop. Also notice that the for each method was not defined in the list interface before Java 8. This method was introduced in Java 8 just to utilize the Lambda expression. So does that mean that the implementations of the list interface, for example ArrayList, has to provide implementation for that method? Not necessary. The default implementation was provided by the list interface itself by using another feature of Java 8 called default methods. If you click this method by pressing Ctrl, you would notice that this method is a default method and is part of the iterable class. And we have already talked about default methods in our previous chapter. Alright, that's it for this video. See you in my next video.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.